Hello again and welcome to the public forum at the group exhibit for hydrogen fuel cells and batteries here at the Hanover Fair 2017. Please come in, sit down and enjoy a complimentary beverage. My name is Michael Sinclair and I will be your moderator for the next discussion. Audience questions are welcome at any time. I'll look out into the audience. If you have a question, please feel free to raise your hand and I'll bring the microphone to your table. Here to talk about nickel metal hydride bipolar battery technology, energy storage that is safe and environmentally friendly, we have the head of product management from Nilar Battery, Mr. Magnus Dahlén. Please join me in welcoming him to the stage.
Hi, thank you.
Thank you, Magnus. So perhaps I could get you to start by introducing yourself, your organization, the products that you make, and the markets that you serve.
Yes, as you said, Magnus Dahlén is my name, and I work at Nilar, a company providing energy storage solutions. What we do is that we manufacture battery packs and offer battery energy storage solutions on system level. Yeah, that's the in short version.
Okay. That's great. So we spoke at the Hanover Fair last year, actually, on this very stage.
Yes.
Tell me, is there anything that's changed in your product offerings from last year?
Quite a lot, actually. We are now more offering systems. So now we can provide turnkey solutions for energy storage to a number of different applications, really, but typically all these smart grid applications, renewable energy. The need for energy storage and that application is what we are targeting with these systems.
So when you say entire systems, what does that include?
It includes the battery packs, which we do ourselves. It includes the battery management systems, which we also do ourselves, of course. And it includes inverters, which you have between the battery and the grid or the other application. The inverters we buy from other companies, of course. We don't do the inverters ourselves. Although we have tested all the inverters and approved the inverters, making sure they work well with our battery and our system.
So for grid-connected battery applications, which markets are you targeting? Is this distributed residential markets or is this larger scale systems?
Larger scale systems down to single households, actually, but larger scale systems is mainly what we are offering at the moment. And this is typically charging electrical vehicles, for example. A lot of interest from that sector. If you're going to charge a number of electrical vehicles, you need high power. Upgrading the grid is expensive, it takes time. So a better solution in many cases is just buying a battery, an energy storage solution. And that is what we provide with our systems.
It seems strange to charge a battery with a battery, but of course it makes a lot of sense because you said of limited power that you can deliver through the grid, the battery can be charged slowly over time and then of course discharged rapidly for rapid charging of vehicles.
Exactly, exactly. Other typical examples are, for example, buildings with photovoltaic or wind energy and load leveling. And there we provide also our systems as an energy backup energy storage to be used when you need. And here also we have addressed safety issues and reliability a lot also, and that's why we have chosen the nickel metal hydride technology.
Yeah, I want to ask more about the safety issues, but first let's talk about nickel metal hydride. Why nickel metal hydride and also why bipolar? What does that mean and why?
Yeah, start with nickel metal hydride. That one was chosen as a chemistry in the batteries we use because of several reasons, but mainly high safety. It's a very good cycle capability. The operating temperature range is large. It's also environmental friendly. There are no heavy metals or other poisonous substances in the batteries. And most of all, it's a very good battery when it comes to recycling. It contains a lot of valuable metal, so it actually is a cost-efficient recycling process available for these kind of batteries.
So if I'm one of your customers and the battery reaches end of life, what is the process to get it recycled?
Could be both melting down or dissolving in acids, depending. It's mostly melting down the batteries for these methods used today. I see that in the future we can have a closed loop on active materials actually from recycled batteries going back in our production line after being refined, of course. Then
And that's not something you offer today, but you imagine you want to offer
I
that.
can see that coming in the future with larger volumes. So I think we will end up with that in that situation.
So you mentioned safety. What makes these batteries different from other batteries in terms of safety?
It's mainly that we have a water-based electrolyte. That's the main difference as compared to lithium-ion batteries. The water-based electrolyte is non-flammable, and also the materials used in the battery is not it's not easy ignited. They don't burn. So that provides a very good safety, which is well proven for the nickel metal hydride system. You can see that on, for example, Toyota Prius has been using nickel metal hydride for many, many years. You can easily see it also in regulations for transport. Lithium-ion having big problems with safety and are heavily regulated. Nickel metal hydride there is almost no regulations at all for nickel metal hydride, making it very much more easy to transport, for example. That's just one example of the high safety level of this system.
So, bipolar. What does
Yes.
bipolar mean?
Yeah, that's our but our invention. Bipolar has been something that many battery manufacturers try to do for many years. We have made it happen with nickel metal hydride now, meaning that, well, it's a bit complicated to explain actually. The current is going perpendicular to the plate surface, which is a big difference. You don't need any intercell connectors at all. We can connect, when our battery packs, 100 cells in series with no connection between cells in form of external connectors.
Those are for very high voltage applications.
For high voltage applications and low voltage also, but that is a very cost-efficient way of doing battery packs. It also enables us to do a very high-quality product at low cost.
So, lithium-based technologies are in the news often. Obviously, Tesla is a big brand in batteries, and they use lithium-based technology. So, how would you compare and contrast nickel metal hydride batteries to the very common lithium technology that gets used in vehicles?
It's mainly the weight. We carry more weight than lithium-ion. Otherwise, we have almost the same cell or the same cycle life. We have a better calendar life, I would say. Nickel batteries are famous for the calendar life, and we say up to 20 years, which is a very strong, long service life for a battery.
So similar life in terms of cycles, but the shelf life, if for intermittent use, would be even longer.
Exactly. If you have the battery on maintenance, for example, just as a standby battery, it will last you a very long time with unaffected performance. The resistance, for example, is very flat over life, so get well predicted.
That sounds ideal for backup power applications.
Yes, it is a very good battery for that. But also for cyclic application. I mean, it is a battery that can spin cycle for a lot.
And it can be shallow cycled and deep cycled?
It can be cycled almost in any way. You can shallow cycle and deep cycle, and you can have it on intermediate state of charge for long times. You can store it on the shelf for a very long time. It is, in general, a very robust and well-proven chemistry.
So the last talk that I moderated, we were talking about fuel cell reliability testing.
Yeah.
I guess I would ask you about battery testing. What do you have to do to qualify a battery's lifetime, and how do you accelerate it for to get an understanding of how long it'll last in the field?
Yeah.
That 20 years, you probably haven't been making this battery for 20 years.
No, we haven't. So that's more a statement based on general performance of nickel batteries, like NiCads, and also nickel metal hydride has been around for consumer grade batteries for a long time. So, but yes, we have to test a lot, and that we are doing. Cycle testing, service life testing takes a lot of time, and that's why research and development on batteries takes such a long time.
Okay, are there any audience questions? Feel free to pipe up at any time and raise your hand. I'll bring the microphone. Let's talk about some of the applications for batteries that you've deployed. We've talked about the pros and the cons of technology, I guess, the weight being the con, but there are many pros. What kinds of applications are you seeing? We also said grid connected. What other applications?
Well, we have some other applications also, hybrid applications, a boat, for example, going with our batteries, a 180 kilowatt hour battery installed in a ferry. transporting people in Stockholm back and forth. We have other types of energy optimizing use. This is also station applications, mainly, where you use the battery as a buffer, just for shifting or load leveling energy, and optimizing the use of energy, for example, in a house or whatever it is. So this is a very, very, very exciting time in the battery business with all this. It is called smart grid, but it's very much, for our part, as we see, connected to renewable energy. Solar farms, wind farms, peak shaving, storing energy, and as I said, increasing number of electrical vehicles and charging infrastructure that can be supported by batteries. And that was what we're targeting with our systems, which is large format batteries. We're talking with batteries in the size of 48 kilowatt hours up to megawatt hours. So it's kind of very large systems.
So for grid-connected applications like that, you need to have some sort of high-level control for the entire system to respond to the grid needs or the power needs. How is that accomplished with your systems?
We have developed a battery management system that controls on cell and battery pack level, of course, as everybody do. But the next step, you have to communicate with an inverter, which takes the energy in and out of the battery. And that we have also, we have inverters which we have kind of qualified for our batteries. So we have all the handshakes and all the software available for a number of inverters that the customers can use, for example, and connect to his system in his end. So that is what we provide, from a cell to inverter, the complete turnkey solution on system level.
But what about the grid level control? That's what I was trying to get at.
Yes, the grid level control, that is what our customers do.
Okay.
We do not control the grid, of course, although our solution is one part of controlling the quality on the grid. Yeah. So we provide the energy storage. Yeah.
Okay. So if there's no other questions, this has been really interesting. So you're one of the few, are you the only nickel metal hydride battery supplier here at the fair?
There are a few still left, otherwise it's very much lithium ion, but it is a very good chemistry as we see it.
Yeah.
And it's used well with the hydrogen fuel cells and batteries theme you have here, actually, since it is a hydrogen-based technology. Right. This is not lithium ion, it's hydrogen ions going back and forth in the battery, so it's similar to fuel cells in many ways, and with a bipolar design, as is used in fuel cells. So it's similar in many ways, but still it's a battery, not a fuel cell. So.
Yeah. So I guess, what do you see as the trends over the next 5 years for nickel metal technology?
Oh, I think we can do a lot with the technology. We are most likely going to optimize power performance and the temperature range, going upwards in temperatures to high temperatures. Nickel metal hydride is well suited for that applications. We can go up to 50 degrees Celsius, we have maybe even higher, and reach low temperature in the same cell design, which is a very strong point. Charging at low temperatures, for example, is, I would say, nickel metal hydride is a very good system to use. If you have to charge at low temperatures. We can use very high charge power down to minus 20 degrees Celsius.
All, again, good features for grid-connected applications, especially in Northern Europe.
Exactly. Minimizing the need for controlling the temperature in the battery installation, which is cost reduction.
Perfect. So for more information, I'd welcome you to visit the Nilar Battery booth. It's behind us if you walk towards the technical forum. It's at D50, so location D50. Make a note of that, and be sure to stop by and speak to Mr. Magnus Dahlén. Thank him with me for joining me on stage today.
Thank you. Thank you.
Up next, we have the Executive VP of Sales and Marketing for McPhee Energy. He'll be speaking on the topic of Simple Fuel, a game-changing hydrogen fueling station. So please stick around for that.